Hi everyone, welcome back to another video of CambiHub, and in today's video we'll be doing IGCSE Computer Science Chapter 2, which is data transmission. Before we begin, I would like to spend few minutes on our website, on our learning portal, because it is really necessary for our Cambanians to know what we do and how they can access our resources. So if you can see in the following screen, this is our CambiHub's learning portal, where obviously the website address is www.cambihub.com. Now, this is all of the information that you can get about CambiHub. You can also access all of the resources. Suppose you're an IGCSE, you can hover over the IGCSE panel and look for your favorite subjects. Click on the subjects, you'll get resources for that. And by clicking on this link on the top, you can also join our WhatsApp community where you can ask your doubts as we are available 24/7. Now, without wasting any more time, let's resume with the video and start with chapter 2. Starting with chapter number 2, these are few entry ticket questions. If you have already studied the chapter, please listen to this carefully. If you have already studied the chapter and you want a revision of the chapter, if you haven't studied, I recommend that you watch the whole video and then come back to the video and watch these questions again. So let's start with the first thing in the chapter, that is data. So the chapter talks about data transmission, and transmission means how the data travels over the internet. This chapter totally talks about all of those things that are required to you to know as a computer science learner, as a computer science student, that how does data travel over the internet. So when we talk about data, data is broken down into smaller parts. They are called packets, right? Like there's delivery of packets in real life, and virtually also in our systems also, the data is traveled over the internet from the sender to the receiver. So this data is broken down into smaller parts, which are called data packet, or they're also called datagrams. Now, typical size of a data packet is around 64 kibibytes, 64 KIB, right? Now let's see you through a physical module, what are the parts of a data packet. Now, as you can see, this is typically how a data packet looks like. If you zoom into a data packet, these are the three parts of the data packet. Obviously, the data packet, all of these three parts of the data packet are connected, right? So the first part of the data packet is called the header. The second part, or the middle part of the data packet, is called the payload. And the last part of the data packet is called the trailer. The last part of the data packet is called the trailer. Now, what does the header of the packet contains? The header of the packet contains the IP address of the source, or the IP address of the sender, and the IP address of the destination. So it knows the address from where it is being sent and to where it has to be delivered to. So it has the address of both. Then the sequence number of packets, because obviously there are a lot of packets. So what is the sequence number of this particular packet? Because when packets travel over the internet, they travel in a random order. So at the end, they need to be arranged in a specific order so that the file can be regenerated, because it's broken down into packets. So once all of the packets are received, the file is regenerated. Then it also includes the size of the packets, right? A typical size of a packet, as we just discussed, is 64 KIB. Now, as you can see, payload contains the actual data of the packet. Obviously, we have broken the data into packets. Now, what is this? But what does this packet hold? The actual data of the packet is in the middle. It is in the payload. And finally, in the trailer, we have a method to identify the end of the packet. The trailer signifies that this is the end of the packet. And we also have error checking methods. These error checking methods are used to check if the packet has been corrupted, if the packet has been damaged during the data transmission. Moving on to the next topic. Moving on to the next topic, which talks about the checks, which talks about the types of checks we conduct for, the types of checks we conduct to check if a packet has been delivered correctly, if the packet is correct, if there's an error in the packet, right? So the first check is called cyclic redundancy checks. Now, this is an error checking method. How are cyclic redundancy checks done? So obviously in computers, everything is stored in binary, in zeros and one. So a packet also has its own value, its own binary value. So in the payload, we are going to add up all of the one bits, right? All of the one bits are added from the payload, because the payload contains the data of the actual data of the packet. So we'll add all of the one digits. right? And then we'll convert it to a hex value. We'll convert it to a hex value. Once we convert it to a hex value, we send the packet over the internet. Now the receiving computer will do the same process again and calculate this hex value. Then this hex value will be matched to the value that the sender has calculated. And if the values match, there is no error. Otherwise, there's an error and the packet needs to be resent. So sender calculates this value and the receiver also calculates. So the sender calculates this value, which is sent to the receiver, and then receiver recalculates this value and they compare that during the data transmission, during the packet was sent, was there any error or everything was totally fine. These are cyclic redundancy checks. Now the next thing that we need to understand is the process of packet switching. Now let's understand packet switching through an interactive module. So let's say we have a sender and we have a receiver. Now there is a connection. There's obviously the sender is connected through their router and the receiver is also connected through their router. Now there's a single line, single communication line or a single wire that has been connected, right? Now this is a data packet and this is a whole, data file that needs to be sent to the sender from sender A's router. It needs to be sent to sender B's router. So we send the whole packet. Now, this is the first thing. If you see, this is a larger data packet which needs to be sent through a single communication line. So since it's pretty large, the single communication line or this wire will also have a lot of load. It will also have a huge load, right? Hence, this process is typically slower and it is also not secure. If a hacker is able to access this communication line, or if the hacker is able to hack this line, then the hacker will be able to get all of the data. So we created this process called packet switching, where we divide these packets into multiple parts. As we discussed, we divide this data into multiple packets in multiple parts, which are called the datagrams or data packets. And then we sent it to random routes via the internet. Obviously, there would be other computers in the internet in the world also connected through the routers. So these packets travel through a random route, right? And they receive in a random order here. So they need to be rearranged by the receiver, right? So this is typically a faster process because smaller data is being traveled through each packet, each router here, each communication line here. So there's less load, and all of these parts of the packets, they are traveled simultaneously. So this is a faster process and it is more secure because even if the hacker is able to access one of the communication lines, the hacker will only get one of the data packets and not the whole data file. So this is typically a more secure way. Now we have completed with the module. Let's go and understand packet switching in detail. So if we understand packet switching in theory, because obviously you will be required to, write your answers in the paper at the end. So we must focus on the theory of the packet switching also. So this is what the theory is. The data is broken down into packets and each packet can be sent independently on different routes. Now the router of the sender decides which is the shortest possible path and which is the most efficient path that the router can take. At each stage in the transmission, there are nodes that contain a router. So these are the nodes that contain a router at each stage. At the destination, the packets are arranged in order to construct the original data file. So this is how typically you would make a diagram, because obviously Cambridge has started asking 4-marker diagrams in the paper from the 2024 series. So you would be required to draw these diagrams. Just take a close look of the diagram. This is the sender, these are the data packets, and this is the sender's computer, this is sender's router. We send it via packet switching. I explained you the process here. Right here, the packets, as you can see, they have intentionally not been arranged in order. So they need to be rearranged. And this is the receiver's router and this is receiver's computer. Right? Coming on to the advantages and disadvantages of packet switching. Advantages is that we do not need to set up a single communication line. As I showed in the module, setting up a single communication line is not secure and it is pretty slow. So that's why we do not need to set up a single communication line. Then security obviously is a point, which an advantage to packet switching. And it is possible to overcome a faulty line. For example, if a route is faulty, so the sender's router will decide another best alternative route for the packet. So this is an advantage. And obviously we have high data transmission rate. It is pretty fast. When we talk about the disadvantages of packet switching, packets can get lost during transmission. This is one of the things. This is one of the disadvantages. Packets can get corrupted. There can be data skewing, or there can be mixing up of data. Right? There can be data skewing that can happen. And there is obviously, since so many communication lines are there, it is more prone to errors. Right? There are more, chances of errors in such a case. Hence, it is not a really, it can cause more errors. And there can be delay at destination while packets are getting reordered, because the packets arrive in, random order. They need to be reordered. Now, we just discussed about how packets can get lost. What do we mean by packets can get lost, and what is the solution to that? A solution to that is hopping. Let's understand via a physical module that how hopping works. Suppose this is the packet's route, and the packet, there is some corruption in the packet, and the data where the packet holds that, where it needs to go, what is its route, that data gets corrupted. So obviously the packet will be lost. And to, to stop it from, roaming around via different routers or different routes, keep on roaming around and get lost in the internet forever, we create a process of hop number. So every packet is given a hop number. For example, in this case, suppose initially I decided that the packet has to travel via 6 routers only. So I will give the packet's hop number to be 6. But suppose this packet is lost and it is going through random routers. As soon as it reaches a router, I will subtract this hop value. So suppose it reached the first router, I will subtract the hop value to, sorry, I will subtract the hop value to 5. It reaches the second router, I will subtract the hop value to 4. It reaches the third router, I will subtract the hop value to 3. It reaches the fourth, I will subtract it to 2. It reaches the first, I'll subtract it to 1. Now, since the hop value is 1 now, when it reaches an extra router, which is not required, its hop number will become 0. As soon as its hop number becomes 0, the packet will be destroyed. The packet will be destroyed so that it does not keeps on roaming around on the internet. Let's see it via the theory. Now, as you can see in this module, these are the routers, right? This is what we discussed in hop number. Sometimes packet get lost and they can keep hopping on routers. So to prevent this, we create an hop number. As soon as the packet reaches a router, its hop number is subtracted, right? It is subtracted. Suppose the router, it only had to, travel through 5 routers, and there is, more than, it travels more, right? Its hop number will get 0 at the end, and then the packet is self-destroyed. Moving on to the next thing, let's talk about the transmission of data. Now, transmission of data is of two types. It can be over short distances, and it also can be over long distances. Right? Now, during this transmission of data, there are few communication protocols. These communication protocols are rules that the data needs to follow while it is being transmitted on the internet. Right? Now, what are these protocols? What are the factors that we need to keep in the mind? The direction of the data transmission, method of the data transmission, and how will the data will be synchronized. Right? Data can be one way, both way, and both ways simultaneously. Now, if you are confused with this diagram, this is a summary of whatever we are going to do next. So if you're confused, just after whatever we do next, come back to this and understand it again. So let's move ahead and let's talk about everything in detail. Right now, all of these diagrams that I show you right now, they are very detailed. Before we come to the diagrams, let's understand it through a module. Let's understand the types of data transmission using the PPT modules. The first type of data transmission is serial data transmission. In serial data transmission, obviously, we have a sender, we have a receiver. This is a single communication line, and we need to travel multiple bits. Now, in serial data transmission, one bit can travel at a time. Only one bit can travel through this single communication line. Whereas when we talk about a parallel data transmission, obviously we have a sender, we have a receiver. Here, multiple bits can travel at a time. Multiple bits can travel at a time through different communication lines. In serial, we only add a single communication line. In parallel, we have multiple communication lines. Moving on to simplex data transmission. Now, please do not get confused between serial and simplex data transmission. In simplex data transmission, we have a sender, we have a receiver. We do not talk about the channels or the amount of bits that can travel. With simplex data transmission, we only talk about the direction. So data can travel in only one way. So only from the sender to the receiver. Data can only travel in one way. It cannot travel in both direction. When we talk about half duplex data transmission, obviously we have a sender and we have a receiver. And here, please again, make sure we are only talking about the direction. We're not talking about the number of bits or the number of communication lines. In half duplex data transmission, this data packet can travel in both directions, but not at the same time. So it can travel from sender to receiver and receiver to sender both, but not at the same time. Whereas when we talk about full duplex transmission, please ignore this. This is not half. This should be full. Let me just rectify that. It should be full data transmission, not half duplex. It should be full duplex data transmission. When we talk about full duplex data transmission, the data can travel in both directions with the sender to the receiver, receiver to the sender, and at the same time too. So it can be at the same time. Now let's talk about the advantages and disadvantages and the differences between serial and parallel. So serial and parallel, again, serial only has a single communication line as we saw in the module, whereas parallel has multiple channels. Serial is best suitable for long distances since it's a single wire, we can make it long also, but it is pretty slow because only one bit at a time is transmitted. For parallel, since we have multiple wires, it is only for a short distances. So the particular distance for serial and parallel is 5 meters, right? Is 5 meters. Parallel, short distances and multiple bits at a time. So parallel is faster than serial, right? Serial is obviously cheaper since only, it's a simple setup. We only need one communication line, whereas parallel, we need multiple wires. So it is, even though it's faster, but it's expensive. Then serial has less chances of data skewing since it's a single wire. But in parallel, we have a much complex setup. We have multiple wires. So there are more chances of errors and data skewing. Data skewing means mixing up of data or data getting damaged or corrupted, right? This is one bit at a time. This is how serial data transmission looks like. This is multiple bits at a time. Here S is the sender and R is the receiver. Please make that in mind. Now this is serial and parallel. We talk about simplex, half duplex and full duplex also. See, serial and parallel only talk about the number of bits and the amount of channels. Whereas simplex, half duplex and full duplex, they talk about the direction also. They only talk about the direction. So simplex is one way. Half duplex is both ways, but not at the same time. And full duplex is both ways, even at the same time, simultaneously. Right? Now, combinations can be made. Serial full duplex transmission means that the transmission is of one bit at a time. There is a single communication line, but data can travel both directions simultaneously. So please keep this in mind because examiners, questions will be formed in a way where there will be multiple, mixing up of this. So do not get confused with that. Coming to universal serial bus, which is USB. So USB, obviously we all have used USB. There are different kinds of USB. USB-A is the USB that we use in pen drives. USB-C is the USB that you probably use to charge your phone, or the lightning port, lightning cable that we have in iPhones is also a type of USB which has this charging facility. So USB is of many types. Majorly, we'll be discussing about USB-A here, right? We'll be talking about USB-A here. And USB is serial data transmission. So all of the advantages and disadvantages of serial data transmission will apply to USB also. However, there are few extra advantages and disadvantages of USB. Advantages is it gets automatically connected. Now USB gets automatically connected and we do not need to, install the drivers. Automatically they are installed by the system. It can be plugged in any way, right? It can be plugged in any way. It also charges the device. This is also, and this is another advantage, right? Now, disadvantages are that maximum cable length is 5 meters only. So please remember this, serial cable length is less than 5 meters only. So maximum cable length it can get is 5 meters only. Now, version 1, the first version USBs, as the versions continue, the older versions will not be compatible by the latest computers. So that is a disadvantage. It is better, it is faster, right? There are a lot of alternates available. However, Ethernet is a better alternate of USB. And, you can write any other advantages and disadvantages of serial data transmission here also. Coming to the next topic, which is error detection method. So we discussed CRC, cyclic redundancy checks, at the start. We also need to discuss what are the other error detection methods that detect errors if there's, that detect errors during transmission. If there's an error during the data transmission that has occurred. So all of these are the types. We have ARQ, parity checks, checksum, check digit, and echo check, right? Now, why are these errors caused? Why do packets get lost? Why is data skewing? Why does data skewing happen? So why and how? Number one is interference. Interference in the signal can cause this signal attenuation, which is also, distortion in the signals. Packets getting lost. Packets obviously can get lost. There can be data skewing. The data can be mixed up and data can get corrupted. Right? The first kind of check that we need to understand is the parity check. Now, this is also called the odd even check, right? There are two types of parity checks. We have a parity bit and we have a parity block. So before sending the data, how does this parity check work? Before sending the data, both sender and the receiver, they make an agreement, right? A parity can be of two types. It can be odd and it can be even. So both sender and receiver will agree that this time the parity will be odd or this time the parity will be even. So we'll calculate the number of ones, right? We'll count the number of ones. If the number of ones, for example, there are 5 ones, the parity is odd. If there are 6 ones, the parity is even. So we'll count the number of ones, and if they are odd, odd parity is chosen, right? If the parity doesn't match at the receiving end, so the sender and receiver will agree whether it's an odd parity or even parity. They'll count the number of ones and check if the parity is true. If the sender counts the number of ones and sees that it's an odd parity, and if the receiver counts the number of ones and sees if it's an even parity, then there's an error that has occurred. So parity bit, how does it work? So 10100011, right? So we'll count the number of ones. So 1, 2, 3, 4. There are 4 ones. So this has even parity. Let's see the other one. 1, 2, 3. This has 3 ones, so this has odd parity. We also have parity block, right? Now, why is parity block better than parity bit? So parity block is better than parity bit because parity block will checks errors row wise also, bits wise also, and bytes wise also. So row wise and column wise, it checks for errors. So it will exactly tell you the spot where the error is. It will exactly tell you the box where the error is. Whereas when we talk about parity bit, for example, this data was being transmitted, it has 4 ones. For example, there's transposition of bits. This 0 became 1 and this 1 became 0. So this 1 came here, right? Even though this 1 came here and 0 came here, the number of ones are 4. The number of ones are 4. So what I'm trying to explain is that suppose this was the data that was sent initially, but after that some error occurred and this became 1, 0, 1, 0, 0, 1, 0, 1. Now, even though these two bits have interchanged, the number of ones remain to be 4. The number of ones are still 4. That's why even if there's a transposition of bits, parity bit cannot detect that, whereas a parity block will tell you the exact location of the error that has occurred. Moving on to the next, error checking method, which is checksum. How does checksum work? It checks if the data has been changed or the data has been corrupted. So both sender and receiver will, using a mathematical algorithm, right, they'll calculate a checksum value. Now, this is a mathematical algorithm. We do not need to look what that algorithm is, but both sender and receiver will calculate. The sender will first calculate before sending this data, it will calculate the checksum using that mathematical algorithm. So the checksum is also sent with this data. Now the receiving computer will recalculate using the same mathematical algorithm and it will compare with the sender's calculation. If the calculations or if the values match, then there is no error. If they don't match, then there's an error and the data needs to be resent. Coming to the echo check. Now the echo check is when we send, echo check is the worst possible check you'll see here. Reason being, echo check is pretty simple and there are many chances of, misunderstanding with echo checks. Why? Let's see. So first we have a sender, we have a receiver. The data is sent to the receiver, right? Then the receiver sends this data back to the sender. So there was initially this file A and the receiver will resend this file A dash to the sender. Now the sender will compare A and A dash and check if the files match. If the files match, then there is no error that has occurred during transmission. If they don't match, then there's an error. But there is a problem with echo check. The disadvantage with echo check is we won't be able to find whether the error has been during during the transmission when sender sent it to the receiver, or the error came when the receiver sent it to the sender. So this is a pretty bad method. To remember it, you can say that it's like an echo. So that's why it's an echo check. Let's come to check digit. Check digit is a final digit. So along with our whatever the binary value is, for example 1011, whatever the value is, at the end we reserve a value for the check digit. So these are the two methods, ISBN 13 and modulo 11. You do not need to learn this method even though it's there in your higher education book, but you do not need to learn that because that will be given in the exam, right? That the algorithm is always given in the exam with an example. So using the mathematical algorithm, the sender will calculate it, and this data is, along with at the end of the data, it is sent, and then the receiver will recalculate this data, using that algorithm, ISBN 13 or module 11, and then they'll check. If the values match, then there is no error. If the values do not match, there's an error, and the packet needs to be resent. Coming on to the next topic, which is automated and repeated requests. So automated and repeated requests work on two things. First thing is a positive acknowledgement and a negative acknowledgement and a timeout. So if I say, for example, if I give you a message, right? If I say you need to complete your work, right? Now, if I say, have you completed your work? If you have completed your work, you would say yes. So this is a positive acknowledgement from your side. If I say, if you have not completed your work, then you would answer no. That is a negative acknowledgement. So that is what it happens. That is what happens here. There can be three cases. In case one, if data is sent correctly, the receiver will send a positive acknowledgement. Okay, sender, here is my positive acknowledgement. The data, I have received the data correctly. If it is incorrectly, there's an error, the receiver will send a negative acknowledgement. It will say to the sender that no, I have not received the data correctly. Please resend it to me. That's a negative acknowledgement. And the third case will be that there is no acknowledgement at all, which means the receiver didn't receive the data packet, right? When there is no acknowledgement, it could be that the receiver has some issue or the data did not reach correctly. So the sender will automatically wait for a timeout period, right? So sender will see, okay, it's 15 seconds now. 15 seconds is my timeout. Until this time, until, ideally the acknowledgement should have been received, but since I have not received, I'll resend the packet myself. So sender will resend it automatically. So this is a timeout. If there's no acknowledgement at all, then after the timeout finishes, the sender will automatically resend it to the receiver. Coming to the last topic of this chapter, which talks about encryption. There are two types of encryption. There is asymmetric encryption and there is symmetric encryption. When we talk about encryption, encryption is when we scramble data. When we scramble data, we have plain text, normal data. We scramble our data into a secure, a scrambled file, which is called ciphertext. So sender will first send the plain text using a encryption algorithm. Then the encryption key will lock this algorithm, right? What is this encryption key? It will scramble this data and convert it to ciphertext. Then it is sent over the internet. Then the receiver has a decryption algorithm. It will unlock this data and it will make the data normal. So this is encryption. This is used for security, obviously, right? So encryption is of two types. We have symmetric and asymmetric. In symmetric encryption, there is only one key, right? A single key, the same public key, is used to lock and unlock the data. So sender and receiver both have this public key. However, this is not same because using the same key, we are locking and unlocking the data, right? See, key is used to explain the concept to you, but it is not a key. It is an algorithm that converts plain text to ciphertext. So key is used here to just explain the concept to you. Coming on to the asymmetric encryption. To explain asymmetric encryption, I always give an example of banks. Right? So if you have a locker at a bank, right? If you have a locker at a bank, the locker will include two keyholes. One key is with you and one key is with the bank. So if you want to unlock your locker, the bank would have to put their key and you would also have put your key, right? So both keys need to be put to unlock the locker, and both keys are different. Both keyholes are different. The shapes are different. The keys are different. When both keys are entered, then only the locker will be opened. So suppose your key is stolen, the whatever whoever is the thief, they won't be able to open your locker. Or if the bank is at a crisis, if there's a thief at the bank, then also you would have your second key, so nobody will able to open your locker. So sender has two mathematically keys, identical keys. However, one key cannot generate from other because both keys are different. One is a public key, one is a private key. So sender will first send the public key, which can be used to de-encrypt the data. It will send it public key to the receiver, and using the public key, it will encrypt the data, right? And the receiver using the private key, it will decrypt the data. It will unlock the data. So sender also has a key. Sender makes both of the keys and it sends one of the keys to the receiver, right? So the receiver uses the sender's private key to decrypt the data, and the sender uses the public key to encrypt the data. Okay, everyone, I hope that chapter 2 is clear to you, even though you might feel that the chapter is a bit rushed. That's because the chapter is pretty big and all of the IGCSE chapters, covering it in one video is not possible at all, but we are doing it. We'll create detailed videos in future, or if you're watching this video after 1 or 2 years, you might see a detailed video on the channel. So please go onto the channel, check the playlists. And if you have your IGCSEs, if you have your exam, if you have your GCSEs, if you have your O levels, then all the best for them, all the best for them. And I wish you luck. I wish you can score good, you can score good. And please do subscribe to CambiHub, and I wish all the best to you guys. I hope that you all get an A star, right? You all get an A star. Now, I told you the portal. You can go to the portal, join our WhatsApp community. We do conduct free sessions there. We also have a tuition service. So if you want to avail for any subject, you can message the admins. So please do check out the community. This is Pranay Arora signing off from CambiHub. I'll meet you in the next lecture video.